This is the reassessment for the forces quiz. So first we need to draw this free body diagram. I'm just going to redraw the pendulum diagram we're given over here. And now we gotta, the first force we have is always gravity. And then the next force we have is the little string that's attaching the pendulum to the wall. And I'm going to label it tension and then horizontal, TH. And then we have another tension in the string at an angle, and this is the tension between the pendulum and the ceiling. And this is at a 30-degree angle, but I'm not going to include that in the force diagram. And now we need to find the tension of the horizontal string. And so first I'm going to write out the forces equation. And in order to solve this problem, I'm going to redraw the free body diagram that we had before. And what's tricky about this problem is that there are tensions going at different angles. So in order to find the tension of the horizontal, we also have to take into account the tension of the pendulum, but only the x component of it. So I'm going to write out tension of the horizontal, since it's in the positive direction, minus the tension of px. And so that equals mass times acceleration, but there's no acceleration currently going on. And so if we write out this equation, we get TH equals, and TPX is simply, if we look at the angle, sorry, it's a bit messy. TP we have over here, and then TP sine theta, since it is the opposite of the 30-degree angle we are being given. So now we need to figure out what TP is. So now we can use the y component to figure out TP. So I'm going to use the forces equation again. And since tension is going up and the force of gravity is going down, it's tension Py minus force of gravity, and that equals 0 since it's not accelerating. And then we're going to set these two parts equal to each other. Force of gravity, okay, tension Py is going to equal mass times acceleration gravity. And then tension Py is Tp cosine theta, since it is adjacent to the angle. Since we have both the x and the y components, I'm going to put them over each other using the triangle theorem. So we have Tp of both. So if we write it out, it's going to look like this. Alright. And now we have the tension horizontal in our formula. So we just need to solve for that. So first thing we need to do, I'm just going to rewrite this real quick. And sine over cosine is always tangent, so I'm going to write tangent, and I'm going to plug in the 30 degrees that we have. And so if we rearrange the equation, tension of horizontal equals mg tan of 30, and then simply just plug in your mass and the acceleration of gravity into the equation, and you should have the right answer. So now it's time to find the lowest position of the pendulum, and we want to know its velocity at the bottom. So first I'm going to establish which one's the initial and which one's the final position, and then I'm going to use the equation, the energy equation formula, since energy is not lost, it just changes form. So we have potential energy and kinetic energy at the beginning, and we're going to set that equal to the potential energy and kinetic energy at the end. And in here, I'm just going to write out the equations for each. Make sure you specify the different heights and the different velocities of each, since they will be different at those two positions. And now since the velocity at the start is 0, since it's just hanging by tension of two strings, we can remove that from the equation. And then the height at the bottom, I'm just going to set that to 0 to make it easier to calculate things. So we have the potential energy at when it's the highest equals the kinetic energy at the bottom. And of course, that where it's highest has the highest potential energy, and where it's lowest has the highest kinetic energy as well. And so, if we write this out, we want to find the final velocity. So we just separate the equation and let's get everything in there. So 2gh. So now I gotta figure out h. Now this I had a bit of trouble finding during on the test, since it doesn't straight out give you the height. Easy mistake is to put the height as 2.3 meters. But what you need to do here is again use the sines and cosines triangle theorem. So you know L is the hypotenuse, and then so the height, change in height, would be cosine L. So and then you would have to subtract that from the height to find the little part at the end. So if you plug this all into the equation, you should get 2.5 meters per second. That's the final velocity.